Hi guys, we're taking a peek at, in the dynamic section, problems 32 to 37. And these problems we're dealing with, it looks like just drawing free body diagrams. So we're going to take a peek at a couple of these. Okay, so let's look at number 33, where we have a wooden block that moves at a constant speed on a rough horizontal surface. Draw a free body diagram clearly showing all the forces applied to the block. Compare the magnitudes and directions. So in this case, it doesn't give us any numbers, which actually makes it a bit easier. We're going to start with a rough diagram of what we're looking at, and then we'll transfer it over to a free body. So there's our block. It's moving constantly. We don't know which way, but it's moving constantly to a rough horizontal surface. So there is some friction there. So what I would do is I would draw in my force applied, because something is causing this thing to keep moving along that surface. I also want to draw in a smaller arrow to represent the frictional force on the block. Okay, and then we can't forget also about the weight of the block, and then equivalent, the normal force. So we've got all the forces on this block. We've got the applied, the weight, the frictional force, and the normal force. Okay, and these terms you will have to commit to memory, but not that difficult, because N is normal force, force applied, force of friction, and then weight. Okay, so let me go and we'll find one that includes another type of problem, maybe a little bit more difficult. So if you look at number 34, okay, it says a boy pulls a sled horizontally at a constant speed. So I draw a boy. Okay, he's pulling a sled. So here's the sled. Okay, it's all horizontal motion at this point. Show all the forces on the sled. Here's the sled. Okay, here's the force applied. Okay, we've got some friction here. Again, just like the block, we've got weight and we've got the normal force. Now, what I failed to mention with the free body diagram is that you're not going to draw any really pictures for your final answer. So the final answer will just be a dot, which shows force applied, force of friction, weight, normal force. So that picture right there is what a free body diagram actually is. We don't need to draw the actual picture here. It's kind of nice to get it done first and then transfer it over. Now once you start getting good at this, you're just going to draw just dots. So this one will be the same thing, except the force applied is this way, force of friction is this way, weight and then the normal force are that way. So just a little difference in the direction of the motion. All right, hopefully that helps with free body diagrams.